Hello everyone, we are EpiSense. We aim to create a point-of-care tool that can measure free valproate and hence provide an easy and safe solution for epileptic patients. In this short presentation, we will go over the problem, the current solution we have, and also the future that we foresee for our technology. As an epileptic patient, one of the major concerns is knowing whether the valproate concentration in your bloodstream is high enough. Well, with the EpiSense biosensor, you can simply analyze one drop of your blood plasma on our cartridge and then just press a simple button on the device. Let's see what happens inside. At therapeutic concentrations, over 90% of the valproate binds to blood plasma proteins, primarily albumin. We are essentially interested in only the free valproate concentrations, since this is the active fraction. So a major component of our EpiSense system is to isolate the free valproate from the albumin-bound valproate. For this purpose, we use magnetic particles that will catch the albumin and therefore the valproate linked to it as well. To implement this strategy, we have used albumin trap, which is composed of two wells. In the first well, we use external electromagnetic waves in order to mix the components and aid the albumin depletion. In the second well, the remaining magnetic particles are captured, such that only the free valproate molecules move forward. To accomplish signal generation in the EpiSense device, we use an interesting component called DNazymes. These are single-stranded DNA molecules that show catalytic activity. To generate fluorescence, the DNazyme binds to its complementary substrate. This way, the DNazyme will convert to its active conformation, allowing substrate cleavage and therefore signal generation. So it removes the light-blocking quencher from the light-generating fluorophore. We have shown experimentally that we are able to bind DNazymes to valproate. So at the detection zone, we create a competitive assay. And this is between the free valproate and the previously added DNazymes bound to the valproate. After a simple wash, we will add the substrate and generate the fluorescence. So the strength of this signal will inversely correspond to the amount of free valproate present in the sample. If we record a high signal, then we can say that the blood plasma sample had low concentration of free valproate. In this image, we show the proof of concept for our simple chip. This microfluidics technology involves having a red liquid, which represents the sample, the green and yellow colored liquids that denote the reagent, and the simple pump that is shown on the bottom, which composed of the working liquid, which is absorbed by the porous material, and hence the pressure gradient is created towards the right. As you can see, we have experimental proof of the pressure gradient. It is pulled towards the right direction. So the sample moves over the detection zone, which is the well over there, and then the green reagent follows it. What we can gather from this is that Simple is a self-powered system, as also cheap to make, and it has a programmable constant flow rate. So in conclusion, we give you the EpiSense experience in a nutshell. As an epileptic patient, you can apply one drop of your blood plasma to the chip and achieve an easy-to-read result. Other advantages are our unique magnetic particles used for mixing and albumin removal, the DNazyme-driven fluorescence. And by integrating all these components within an Arduino-based device, EpiSense will be one of the most user-friendly systems for epilepsy patients available in the market. At the end of the day, we hope for a happy experience for you as well as all epileptic patients. Thank you for listening.